Okay, so if I look at 71, 71 will take 30 seconds. Listen up. 71. So recognizing graphs of types of functions. So we have three basic functions we've talked about so far in this class. First one is a linear function. And a linear function has an exponent of 1. So this is x to the first power. So a linear function has x and y both to the first power. So an example would be like y equals 2x minus 1. X is to the first power. That is linear. So when you graph this, which we talked about the first 9 weeks, you're going to go down 1, put a point. That's your y-intercept. How do I get the next point? Up 2, right 1. That's your slope, 2 over 1. Okay, the next one is quadratic. We talked about quadratics a couple weeks ago. What's kind of the basic form for quadratic? No. How do I know a function? No. How do I know a function is quadratic? It has to have what? Squared. So your basic form is ax squared plus bx plus c. That's standard form. So it's quadratic if you see is squared. And the graph of quadratic will give me a what? Parabola. So we'll just do kind of a generic shape. We won't be exact. But a quadratic, you'll see an x squared, and it will give you a parabola. What we just got done talking, done talking about two other ones. We have exponential. Okay, how do I tell whether an equation is exponential? It's in the name, don't make it harder than it is. What is an exponent? What is the exponent? No, your variable is your exponent. So 2 to the x power. So you know it's exponential if your variable is in the exponent form. So x is the exponent. 2 is the base, x is the exponent. The graph looks like has exponential, goes through that, and it looks something like that. So it curves that way with an asymptote at y equals 0. Logarithmic, we talked about graphing yesterday. Logarithmic is the inverse of exponential, which means it's going to kind of be flipped. So logarithmic, and we'll talk about what exponential is, or what it inverse looks like. Logarithmic looks something like this. You're going to have a log, so log base a of x, or something like that. And that goes through 1, 0, so it's kind of switched with exponential. So instead of going through 0, 1, it goes through 1, 0, and it has a vertical asymptote. And that's it. Okay, so those are kind of the 4 basic graphs. So the last page of your homework is going to give you a graph and ask you to identify it, and all you need to do is go through and identify it. So if you flip to the last page of the Unit 2 homework, it's on the very back page. All you're going to do is, I'm not going to give you time to work on it now because it'll take you 30 seconds. Yes?
Did you say that Thursday you'll give us time to do it?
Yeah, I will. The notes won't take very long today. I want to make sure I got through them though. So if you look on the very back page, all you have to do, it gives you graphs. So it gives you graphs like this, and you're just labeling it as linear, quadratic, exponential. Linear is a line, quadratic's parabola, exponential has that curve. That's it. So that won't take you very long on the very back, okay? So,
can we just put A, B, or C instead of...
Yeah, you can just put A, B, or C, that's fine. Okay, and then we're going to look at 72 as well today. So neither one of these are going to take super long, so I just want to get through them so that way you can work on whatever. If you're done with yesterday's, and you can start working on today, so that's why I want to get through these. Okay, let's look at inverse. So inverse, we've talked about inverse before. Inverse is a fancy math word that means opposite, which you've talked about. So you've done inverse when you've done like equations, and I want to do the negative 5 over, so I add 5 to both sides. So when I'm talking about an inverse of a function, we are talking about opposite, and you'll be able to tell that. So the first one is going to be find the inverse. And there's 2 steps, and it's pretty straightforward. You've done it before, so don't make it harder than it is. First step, switch x and y. And the second step is to solve for y. Okay, let's look at an example. That's all you do. Let's look at an example. Let's say I have f of x equals negative 2x plus 10 over 9. Okay, if I look at f of x is the same thing as y. So you just need to know when I'm looking at f of x, you can just replace it with y, the whole thing. So instead of f of x, if you want to cross it off and put y equals, f of x is the same thing as y. So step 1, we're going to switch x and y. So x goes here, y goes where x is. Very doable. So if you want to change f of x to y first, and then switch x and y, and then I want to solve this equation for y, which we've done before. What do I do first to solve this equation for y? Multiply by 9. So I have 9x equals negative 2y plus 10. What do I do next?
Subtract 10.
Minus 10. Minus 10. I cannot combine the 9x minus 10 because 9 has an x. So I just put 9x minus 10. Negative 2y. Divide by negative 2. And then you can leave it, if you want to make it a decimal you can, but you can also just leave it as this, 9x minus 10 over negative 2 equals y. We're not graphing it, so you don't necessarily need to find the slope and y-intercept. You can just leave it like that if you want to. And that is your inverse. So that's all you do. Switch x and y, solve for y. You could write it but you'd have to divide the 9 by negative 2. So it'd be negative 9 halves x plus 5 if you want to. Because you have to. You're dividing this whole side by negative 2. Okay, that is what it is. Yeah, so you can either divide it out, but since I'm not graphing it, if you're not graphing it, you don't necessarily have to worry about dividing it out, but you could if you want to. Okay, any questions on that one?
No, sir.
Okay, let's look at another one. Let's look at one like... what did I just do? I just had the homework up.
That's right, my wrist.
Sorry. Hopefully it wasn't a spider.
I was up all night issue.
Okay, let's look at one like this. Let's have one like this. Let's say I have h of n. H of n equals negative 5 minus 1/3 n. Okay, so h of n is the same as f of x. So anytime you have like this part, this whole left side is just the same as y. So you can just cross it out and put y, that's fine. So whether it's f of x or h of n or t of n or whatever, it doesn't matter. It's just y.
Does it matter like if it's blank and blank? Like
You can have any variables, it doesn't matter. Just the whole thing is y. So now, this is n. So again, if it's whatever variables they choose to use, it doesn't really matter, but you switch them. So this is y and n. So instead of switching x and y, you're going to switch y and n. So it's going to be n equals negative 5 minus 1/3 y. So it doesn't matter. Sometimes they might have different variables in x or y. You do the same process. You just switch x, which is n, and you switch n and y in this case. And then I solve it for y. So what would I do first to solve this for y? Add 5, like I said. It's kind of different, but you've done the process before. N plus 5 is equal to negative 1/3 y. Multiply by, no. You could divide by negative 1/3, which is the same as multiplying by negative 3. So either way you want to. You could just multiply by negative 3. So I have negative 3 times n plus 5 equals y. And then go ahead and distribute. So negative 3n minus 15 equals y. And that's it. So it's different. We haven't done exactly this, but you know how to solve for it. You switch and solve for y. Yes?
Where?
It's in the next section. Whatever it is.
Oh, I found it.
I'll look at them all in a second. Okay, any questions on that one?
I'm gonna start too.
Okay, no, just wait. We're going to finish one section of notes. One more section and we'll be done. I want to get through all the sections real quick. This last section won't take very long, but I want to get through them so that way you don't have to wait on me taking more to be able to work ahead. Okay, the next section, you are going to take it one step further and you are going to graph.
Wait, are we on the same page?
Yep, still on 72. So it's going to say graph. The first lesson took like 2 minutes. Graph and find the inverse. Okay? So we're going to graph and find the inverse. So we're going to take it one step further and we're going to graph it. So let's say I have one like this. F of x. Okay. Let's say I have one like this. F of x equals x minus 1 over 4. Now, if I look at this, we are going to graph this. So I don't want to leave this all over 4 because I'm going to graph it. So I want to be able to, I want to actually divide by 4 so I can find the slope and y-intercept. F of x is the same as y, so you can put y equals. What's going to go in front of x? 1 over, don't overthink this, 4 1/4. So 1/4 x minus 1 over 4, which is 1 over 4. 1/4, you could put 0.25 if you want to because it's the y-intercept, I don't really care. But since we're going to graph this, actually divide it out if you need to. So let's get this line graphed real quick, which we've done before. So yes, same idea. So if I look at this is kind of weird. My y-intercept is a negative 1/4. So it doesn't need to be perfect, but it's going to be a little bit past 0. So negative 1/4, a y-intercept is going to be a little bit past 0. Not quite halfway, kind of halfway between half and 0.
And then it should go what?
It's going to go rise over run. Your slope is a 4, so you're going to go up 1. Now, when you go up 1, you don't go all the way to 1 because 1 would just be about here. No, a little bit under 1 because it'd be 1. So if you go up 1, it's right here. Over 4 will be something like this. So if you have a fraction for a y-intercept, just estimate the best you can. So that is this graph. So all you're going to do is you're going to graph lines like we graphed before, and then you're going to graph the inverse and find that line. No, you have to graph the original and then you have to find the inverse and graph it. But basically all you're doing is graphing 2 lines. Okay? Now let's find the inverse. So if I need to find the inverse, you switch x and y and solve for y. So if f of x is y, when I switch x and y, it's going to be x equals y minus 1 over 4. So to find the inverse, just like I did, you switch x and y. So x is in front, y is where x was. And then you solve for y. What would I do first to solve for y? Multiply by 4. So 4x equals y minus 1. What do I do next? Equals y. And then you graph it. What's the y-intercept? 1. What's your slope?
Rise 4, left, or
Up 4. 1, 2, 3. 1, 2, 3. We're off the graph. 4. Right 1. Now, we're not worried about intersection. We're not talking about the solution. But what you should notice, here's kind of the point. What you should notice is these are inverses. Inverses will reflect across the line y equals 0. So if I graph the line y equals 0, or sorry, not y equals 0, y equals x. If I graph the line y equals x, my y-intercept is 0. What's my slope? Y equals x. So up 1, right 1, up 1, right 1. You should notice that your two equations, if they are inverses, should reflect across that line, which they do. So this is kind of a characteristic of inverses. They are going to reflect across the line y equals x. So you're going to take y equals x, and you should see it kind of reflects them. It flips them across it, which it does in this case. It's just a characteristic, yeah. Okay. Let's look at one more real quick, since you use Spanish. Okay, let's look at one like let's do one like this. So example 4. Okay, y, if I have g of n equals 1/2 n. Okay, they're using n. Don't worry about the variable. If you want to rewrite it as y equals 1/2 x, it doesn't matter. It's the same thing. So y equals 1/2 x is the same thing. Doesn't matter.
So you can always just replace the variables.
Correct. Yes.
So that means x.
Okay, now let's graph this real quick. So we graph the original. So if I graph the original, what's the y-intercept? Nothing, which is 0.
And you go up 1, right 2.
I go up 1, right 2. So don't make these harder than they are. I know inverse is kind of weird, but we're just graphing two lines and making sure they reflect across y equals x. So here's the first line. So that's the original. Now let's find the inverse. How do I find the inverse? Switch x and y and solve for y. So x equals 1/2 y. How do I get y alone? Multiply by 2, or divide by 1/2, which is the same as multiplying by 2. So 2x equals y. And then graph it. How do I graph 2x equals y? Yep. Your y-intercept is 0 again.
So that means you go up to right 1.
Up to right 1. And there's your line. And again, you should notice these are inverses. So a characteristic of inverses is it reflects across the line y equals x. So 0, 1, 1, something. There's y equals x. Now you don't have to necessarily draw a line y equals x on there, but you need to be able, it's a kind of way to check your answer. It should look like it reflects across, which it does. Not perfect, but close enough. Okay, any questions? Okay, that finishes up Unit 2. So the rest of the time is yours to finish the homework. We will be testing Unit 2 tomorrow. So if you've been absent, please watch the videos, come in and see me before after school, get caught up sometime. So that finishes up Unit 2. The rest of the time is yours to finish Unit 2 homework. It will be due tomorrow.
I must use the bathroom.
Okay.
I will prepare tomorrow.